Welcome back. We were discussing in Fundamental of Electronics about the specialized diodes. To continue further, we will discuss some other types of specialized diodes such as the varistors, current regulator diodes, the step recovery diodes, back diodes, tunnel diodes, and the pin diodes. So these are again some of the other categories of the specialized diodes. Let us start first with varistor. Varistors are required to protect the circuit against the voltage spikes. So when there are transients in the circuit involving the AC line, then the power line faults generally occurs due to lightning and other transient phenomena can introduce voltage dips or spikes on the AC line. These spikes are basically the short over voltage events that sometimes reach up to potential of 2000 volt or more. And there may be some dips where severe voltage drops may take place and they last very less amount of time, maybe in microsecond. The functionality of a varistor is acting as a transient suppressor to protect against the voltage spikes. It is similar to back-to-back Zener diodes with high breakdown voltage in both directions. So we have discussed in very detail about the Zener diodes in the previous lectures. The breakdown voltage of the varistor are generally in the range of 10 volt to 1000 volt. For example, if we take one of the varistor given by the manufacturer, which is V130LA2, has a breakdown voltage of 184 volt, and it can handle a very high amount of current, which is 400 ampere, the peak current. Varistors are generally used for protection mechanism to protect the spikes which are occurring in the power system lines, and they clip this voltage. So they will be connected across a power line. So this is the power line of 120 volt AC, and a varistor, which is to back-to-back Zener diode, is connected across the power line. So the varistor will clip the voltage spikes at the breakdown level. So if there is a voltage spike present, then it will clip. So we have seen that the varistor of a particular nature given by the manufacturer can clip the voltage above 180 volt, protecting the equipment from over voltage damage. So this varistor will protect the entire circuit if there is any over voltage occurring in the circuit due to the transient phenomenon. So the applications of the varistor in AC line filtering are generally used as filters which to protect the transformers and power supplies from the line transients. It is common in devices like surge protectors and line conditioners to ensure stable power supply. So we generally used in surge protectors and line conditioners. So they are acting as a filters. The current regulator diodes, the second category, which ensure the constant current, its functionality is like the Zener diodes that regulate the voltage, and it can regulate the current at a constant value regardless of the changes in the voltage or load. So Zener diodes, which we have discussed earlier, we have seen that they will be regulating the voltage, whereas the current regulator diode, it will maintain a constant current even though there is a change in the voltage due to the load. So the diodes ensure a fixed current flow over a wide range of voltage. So whatever may be the voltage change, the current will remain the same in case of the current regulator diode. The schematic symbol of the current regulator diode is shown by arrow which is pointing upward. So you have a resistor symbol which is having arrow which is pointing upward, and it indicates the control of the current. So the resistor variable, which is 1 to 49 kilo ohms, it is maintaining a constant current even though the voltage may change. So let us take an example of one of the current regulator diode, INF305, which maintain a constant 2 milliampere current even though voltage range changes from 2 to 100 volt. The steady state current present in the circuit even if the load resistance varies from 1 to 49 kilo ohms. So even though there is a change in the load or even there is a change in the voltage, the current will remain the same. So application wise, these are ideal for current limiting in the LED circuits, Weissing transistors, and ensure a stable current in various electronic applications. This will protect the circuits from fluctuating load conditions while maintaining a fixed output current. So the current which is present in the circuit is fixed even though the voltage or the load changes. The third category of specialized diode, we have the step recovery diodes, which are basically acting as a snap effect for voltage frequency multiplication. Special diode behavior, if we see, then it is known for its snap-off features due to its reverse recovery. Alternate name, hence it is given as snap diode due to the sudden reverse current cutoff. If you see the schematic symbol of the step recovery diode, it will include a diode with a rectangular shaped section. So here we can see there is a ordinary diode and there is some shape which is given in the form of a rectangle that indicates the step recovery diodes, and the step recovery behavior will be there. So if we see the input side when the doping level represent near the junction, so the input's AC wave is of a frequency of 10 megahertz. The output whatever we get, that snap up a positive voltage step reaching harmonics. So here you can see there is a sudden reverse of the current. So due to the sudden reverse of the current, there will be a cutoff with the help of the step recovery diode. So if we talk about the operation, it has the unique doping profile because the current density decreases near the junction, leading to the reverse snap-off phenomena. The current behavior in the forward conduction during the positive half cycle, it is acting like a regular silicon diode. During the negative half cycle, when it is reverse biased, then the reverse current will flow for a very short time and the snap to zero. The sudden step in current is reaching harmonics which can be filtered to produce higher frequencies. So it will be producing higher frequencies by cutting off the high frequency component harmonics in the circuit. So the applications of these type of diodes generally by generating the harmonics. Harmonics are basically the multiples of the input frequency, maybe twice, thrice or 4 times. The step recovery diodes are widely used in frequency multiplier circuits. So in frequency multiplier circuit, we will be using the step recovery diodes to convert the input frequency to a higher frequency sine wave through harmonic filtering concept. Other type of diode that we have is the back diode, which is efficient rectification of the weak signals. And these diodes conduct better in the reverse than in the forward direction. So we have the reverse operation better as compared to the forward direction or the forward biased. And they have very low reverse breakdown voltage around 0.1 volt. The schematic symbol of this back diode, it is similar to the Zener-like symbol, where the back diode resembles that of a Zener diode to indicate its reverse conduction behavior. So here you can see this is a back diode which is similar to the Zener diodes, and the input whatever we give in AC form, the output works better in the case of a reverse breakdown voltage. It is similar to the Zener diodes. The doping level in these type of diodes are heavily doped diodes that show Zener effect close to 0 voltage, and the forward conduction occurs near 0.7 volt while the reverse breakdown starts at approximately 0.1 volt. So we can see it is close to 0 volt. Hence we can say that this type of diodes operates quite good in the reverse breakdown region. It rectified the weak signal, so it is useful for signals where the peak amplitude is between 0.1 volt and 0.7 volt. For an example, a 0.5 volt sine wave drives a back diode and a load resistor where the diode does not conduct in the forward direction because 0.5 volt is not enough to turn it on. We require a minimum 0.7 volt. However, in the breakdown region or the reverse region, it rectifies the signal and produces a half-wave signal with a peak of 0.4 volt. So it rectified the weak signal in the reverse biased. Application again, so it is used for weak signal rectification. Back diodes are occasionally used in circuit to rectify low amplitude signals where traditional diodes would not be effective. So in the reverse biased, where the signal is weak, you need to rectify the low amplitude signal. Here we cannot use the traditional diodes. Other type of diode that we have is basically the tunnel diode, and it is mastering the negative resistance. Tunnel diodes are heavily doped diodes that exhibit negative resistance in the forward conduction. So when the diode is in the forward biased, you will be having negative resistance, and the breakdown can occur at 0 volt due to extreme doping level because it is highly doped. Here we can see the schematic symbol of the tunnel diode, which is its unique behavior, and the breakdown will occur at very close to 0 volt. We have a distorted current voltage curve, which we have seen. The forward bias, the diode will demonstrate an unusual curve with a negative resistance region. Negative resistance generally occur between the peak point, which is known as BP, and the valley point. In this region, an increase in voltage results in decrease in current. So the voltage will increase, but the current will decrease. There will be oscillation, and the negative resistance property is key for creating high frequency oscillators that generate sinusoidal signal. So where we require high frequency oscillation to generate the sinusoidal signals, this type of diode plays a very important role. So application, again, we will be in the oscillators. Tunnel diodes are used in high frequency oscillator circuits, which can convert the DC energy into sinusoidal signal. So input is DC, output is AC, which is in the form of sinusoidal. And unlike the traditional generators, they don't require mechanical energy. So in machines, we have discussed the DC or AC machines, you will be requiring the mechanical energy to convert it in the form of electrical. But here, you don't require any mechanical energy, and the output that you are getting is basically sinusoidal with high frequency oscillation. This is the final topic for the specialized diode. We have the pin diodes, which are variable resistor for the RF signal, radio frequency, and microwave applications. Pin diodes consist of an intrinsic semiconductor material placed in between P-type and N-type region. The unique structure allows them to operate as a variable resistor in the frequencies of radio frequencies or microwave frequencies. We have discussed about the intrinsic and extrinsic semiconductor in detail in lecture 1 of electronics. So here you can see the pin diode. So here you have, as the name suggests, we have P-type semiconductor and N-type semiconductor. And here you have the intrinsic region. So the diode, which is represented in the form of a pin, so you will be having in this form where it represents two capacitor lines or straight lines in the form of series resistance. So if you see the curve with respect to forward current, when it is increased, then the resistance will fall. So series resistance will fall when the forward current will increase. So during the forward bias, it acts as a current controlled resistor because the current is changing, so the resistance is changing. As the forward current increases, the series resistance decreases. In the reverse bias condition, it functions as a fixed capacitor where reverse bias making it useful in high frequency applications. So when we have high frequency AC applications, then it will act as a fixed capacitor in the reverse biased. Applications wise, in the modulator circuit, we will be using widely in RF and microwave modulation system due to its controlled resistance characteristic. So the resistance will be controlled with the help of the current. If we compare all the diodes that we have studied in this particular lecture in the special purpose diode, starting from the Zener diode, LED, 7-segment display, photodiode, optocouplers, laser diodes, Schottky diodes, Varistors, current regulator diode, step recovery diode, BAM diodes, tunnel diode, and pin diode. The key idea and the applications of these diodes in different fields we can see. So Zener diode, we have seen that it operates in the breakdown region specially, and it is main application is as voltage regulator. LEDs, which are the light emitting diodes, they emit non-coherent light. So you will be using for DC or AC indicators in the form of efficient line source. 7-segment indicator can display numbers, and hence we use for measuring instruments. Photodiode have light produce minority carriers and hence act as a detector in the light. Optocoupler combines the LED and photodiode, so it is used in applications as isolators, either in input or output. Laser diodes will emit the coherent light, so we use in CD players, broadband communications. Schottky diodes has no charge storage, hence we use in high frequency rectifiers. Varistor diodes act like a variable capacitance and hence use TV and receiver tuners. Varistors will break down both ways, so we use for spike protectors. Current regulator diodes hold constant current, so current regulator principle will be there. Step recovery diodes snap up during reverse conditions, so frequency multiplier we will be using. Back diode will conduct better in reverse direction, reverse biased, so weak signal rectification can be possible. Tunnel diode has a negative resistance region, so high frequency oscillator we use it. And pin diode will have control resistance, so RF and microwave communications we use these diodes. So we have completed lecture number 4, where we discussed about many types of special purpose diodes. In lecture number 5, we will start with the BJT fundamentals and how BJTs, bipolar junction transistors, are used in electronics. Thank you for now.